I'm going to give you two ways to think about the answer to this question. Because this happens to be a simple linear regression, in other words, only one predictor, one way to think about this is in terms of correlation. So if you look at these dots, I think it should be clear that the one on the right has a higher correlation between X and Y than the others, right? And you could see that if you wanted to by dividing these into quadrants. And if you do that, you can see that, and I think it's actually on the next slide. Yep, if you do that, divide them into quadrants, you can see that there are lots of points diagonal from each other. In this picture, they're sort of diagonal, but also off the diagonal. And here, the points are more evenly spread across the four quadrants. So that's going to determine the R squared, sorry, the little r. And so the little r will be much bigger here than here, much bigger here than here. And since R squared is just little r squared when you have one predictor, then the picture on the right is going to have the highest R squared. But there's another way to think about it as well, right? And that is by thinking about the definition of R squared as the proportion of variability due to the model as opposed to the residuals. So if you look at any of these Y values, right, Y variables, and you imagine just maybe making a histogram of the Y values of all of these data points, okay? We're thinking about how come these data points don't all have the same Y value. Well, part of that is because each of the different X's has a different Y mean. And the other reason is that the data points are not right at the mean within each group, right? And that's the same thing is true here. If you just made a histogram of the Y values, how come they wouldn't all be identical to each other? Well, because they come from different X's, and the different X groups have different means for Y. And also the data points are spread out away from the mean within each group. Same thing here. Y, if you look, imagine a histogram of the Y values for all these data points all together, they would differ from each other because, well, they have different X values, and the X values come with different means of Y, but also because of these residuals. So you can think of it, the question as, well, in which of these pictures is the variance in Y mostly caused by the fact that there are different X's as opposed to just noise? And in this picture on the right, you could ask, how come these data points that I'm circling up here have such big Y values? Well, the reason is that X is equal to 4. And in this data set, when X is equal to 4, Y is equal to a very big number. How come these data points have relatively low Ys? Well, because X is equal to 1 for those data points. And in this data set, when X is equal to 1, that comes with small Y values. But if you go to this data set over here, you say, oh, how come, this person here has a high value of Y? Well, sure, a little bit it's because Y is correlated with X, but mostly it's because the values of Y deviate from the mean. In other words, it's because that's a big residual, as opposed to because of the fact that Y is related to X. R squared is a measure of how much of the variability in the Y variable is happening because the X's vary as opposed to the residuals.